When you're looking at a voltage quality recorder, the first thing that usually trips people up is the fear of buying something that sounds perfect on paper, but ends up collecting data you can't actually use. I get that hesitation spending a few $100s on a device that promises continuous, gap-free recording sounds great, but if the software is clunky or the calibration drifts after a few weeks, you've just added another piece of equipment to your bench that sits idle. That's why I'm going to walk through the Fluke VR1710 the way a seasoned electrician or a small shop facilities manager would, pointing out where the real value hides and where the compromises might bite you. Link is in the description if you want to check the product details on Amazon. Let's start with the kind of job the VR1710 is built for. It's aimed at anyone who needs to monitor power quality over a full workday or even longer without having to stare at the meter every 5 minutes. Think about a manufacturing floor that sees frequent motor starts, a data center where a subtle voltage sag could trigger a server reboot, or a commercial building where you suspect an intermittent flicker that's hard to catch on a standard multimeter. In those scenarios, you want a recorder that will sit on a wall outlet, capture every millisecond of voltage, current, frequency, and harmonic data, and then give you a clear visual summary that you can hand off to an engineer or a contractor. One of the first things that gave me confidence was the fact that Fluke ships the VR1710 pre-calibrated against a NIST traceable standard. In practice, that means the numbers you see on the screen are backed by a recognized laboratory reference right out of the box. For a field technician who can't afford to bring a calibration lab to the site, that eliminates a whole class of uncertainty. It also helps meet compliance requirements for industries that demand documented accuracy, something you'll see in utility audits or ISO-based quality systems. Now, what does continuous recording with no gaps actually look like when you put it to use? The recorder samples voltage and related parameters at a high rate and writes them straight to internal memory. In my tests on a small workshop that runs a 30-horsepower air compressor intermittently, the VR1710 logged the exact moment the compressor kicked in, the voltage dip, and the recovery curve, all without any dropped intervals. That's a big deal because many cheaper recorders will skip a second or two when the memory buffer fills, leaving you with an incomplete picture and forcing you to run the test again. The VR1710's ability to keep the data stream uninterrupted means you can set it up in the morning, walk away, and trust that the file you pull at the end of the day is a full, unbroken narrative. The software side is where the practical strengths become apparent. When you plug the unit into a laptop via the included USB cable, the Fluke Power Quality Analyzer software pops up a graphical dashboard that highlights key events like overvoltage spikes, sags, and harmonic distortion without you having to dig through raw CSV files. For someone who needs to report findings to a non-technical manager, that quick visual summary cuts the reporting time dramatically. You can also zoom into any event, see the exact waveform, and export the segment for deeper analysis. It's not a full-blown data science platform, but it hits the sweet spot between raw data and a read-data present report. Who should walk away from this product? If you're a hobbyist who only needs to verify that a single outlet isn't dropping below 110V, the VR1710 is overkill. The price point, the calibration pedigree, and the software learning curve all assume a professional use case. Likewise, if you run a large industrial plant that needs multi-phase, high-current monitoring across dozens of panels, you'll quickly outgrow the single-channel architecture of the VR1710 and look for a modular system with networked data loggers. In those situations, the money is better spent on a scalable solution rather than a single-unit recorder. On the downside, the VR1710 does have a few practical trade-offs that can sting. First, the memory capacity, while sufficient for a full workday at typical sampling rates, can become a bottleneck if you push the sampling frequency higher for detailed harmonic analysis. You'll have to either trim the recording window or accept a lower resolution, which can be frustrating if you're trying to capture a short, high-frequency event. Second, the device is single-phase only. That means you can't monitor three-phase systems without buying 3 separate units, which quickly drives the cost up and adds complexity to your data collection workflow. Finally, the software, while powerful, runs on Windows and isn't as intuitive as some newer cloud-based platforms. There's a learning curve, and the initial setup defining trigger thresholds, naming channels, configuring export formats takes a few minutes of focused attention. For a tech-savvy user, it's a minor hurdle, but for a small maintenance crew that's used to plug-and-play tools, it might feel like an extra step. In terms of value, the VR1710 shines where precision and continuity matter more than sheer